Good morning, my students. Limits part 2. So, first thing, indeterminate forms. What are the indeterminate forms? These are the 7 indeterminate forms: 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 1 power infinity, 0, infinity power 0, and 0 power 0. And observe some of the people, they are arguing, sir, 1 power anything is 1, so 1 power infinity is also 1. Here, it is not exactly 1. If it is exactly 1, power tending to infinity is 1 only. So, while calculating the limit of a certain functions, we will get these kind of forms. That means the base function is tending to 1 and the exponent function is tending to infinity. So, tending to 1 power, tending to infinity. 1 power infinity is what here you have to understand. Tending to 1 power, tending to infinity. So, that is indeterminate form. If base is exactly 1, suppose power is tending to infinity, so exactly 1 power infinity is infinity only. Okay. Next, here also tending to 0 by tending to 0. It is also tending to infinity by tending to infinity. Everything. Okay. So these are the 7 indeterminate forms. Next, I am going to discuss some general methods to evaluate limit of a function. The first method is direct substitution method. So in direct substitution method, just will substitute whatever x is tending to a number, that number you will substitute instead of x. For example, limit of 5x plus 3 as x tends to 2. So you put directly x value 2. So what you will get? 5 into 2 plus 3. 5 into 2, 10 plus 3, how much? 13. So 13 is the limit of the function as x tends to 2. So it is not the meaning that we are substituting x value 2. So when x is approaching to 2, 5x plus 3 is approaching to what? 13. It is not the meaning that 5x plus 3 value is 13. 5x plus 3 tending to 13. Okay. Next, sometimes this direct substitution method will be failed. So then according to the given problem, we have to approach certain method. The next method, factorization method. So here if you apply limit x value 3, that means if you apply limit, that means if you substitute x value 3, you will get numerator 0 and denominator also 0. That means 0 by 0, which is indeterminate form. So that means we can't apply limit of the function directly. That means we can't substitute x is equal to 3 directly. Then how to evaluate? So then how we'll come to know? We have to apply factorization method only. So after substituting x value 3, you are getting 0 by 0 form, and also moreover numerator and denominator both are polynomials. What? Both are polynomials. Then we have to approach factorization method. Because after substituting x value 3, you are getting 0 means numerator and denominator common factor will be what? X minus 3. So minimum to minimum common factor will be what? X minus 3. After cancelling that common factor, in the remaining part, if you apply limit or if you put x value 3, you will get the limit of this function. Okay. So here, as x tending to 3, here I am getting 0 by 0 form. Both numerator and denominator are polynomial functions. That means to evaluate this limit of the function, I have to approach what? Factorization method. And that means just you factorize numerator and denominator. So I am writing directly numerator, if you factorize, you will get x minus 3 into x minus 5. Denominator, if you factorize, you will get x minus 3 into x minus 1. So you cancel this common factor. So we are not cancelling 0, 0. We are cancelling tending to 0 to tending to 0. Okay. So now applying the remaining part is what? X minus 5 by x minus 1. In that you put x value 3. That means to get the limit of the function, you put x value 3. If I put x value 3, I will get numerator minus 2, denominator plus 2. Minus 2 by 2 is minus 1. So the limit of this function as x tends to 3 is minus 1. Next, rationalization method. Rationalization method. So here you apply limit of the function directly. Here also 1 plus 0. What you will get? 1. Square root of 1, 1. 1 minus 1, 0. Denominator also x 0. 0 by 0 form. So here whether can we apply factorization method? No, because here both numerator and denominator are not polynomial functions. So here what we have, numerator irrational function. So irrational function, here 1 plus x is a polynomial. Root 1 plus x means nothing but what? 1 plus x whole power 1 by 2. So a polynomial function power rational number is an irrational function. So it is an irrational function. So to evaluate limit of this function, we have to rationalize. So where you are getting irrational factor? In the numerator. So we have to rationalize numerator. Suppose if this irrational factor is appear in the denominator, so we have to rationalize denominator. So suppose for example this problem only ulta is there, reverse is there, then we have to rationalize denominator. If both numerator and denominator both are irrational functions and applying the limit we are getting in this indeterminate form, then we have to rationalize both numerator and denominator. So here I am rationalizing numerator. So root of 1 plus x minus 1 divided by x. So what is the rationalization factor? So root of 1 plus x plus 1 by root of 1 plus x plus 1. So multiply numerators. Numerator in the form of a minus b into a plus b. A minus b into a plus b is a square minus b square. So a square is what? Root 1 plus x whole square. Root 1 plus x whole square is what? 1 plus x minus b square. B square is 1 square is 1. So x into root 1 plus x plus 1. So minus 1 plus 1 get cancelled. What is left here? X. So this x also get cancelled. Then what is left here? 1. Now apply the limit. What you will get? 1 upon 1 plus 0, 1. Root 1 is 1. 1 plus 1 is 2. So thus the answer is what? 1 upon 2. So these things you learn even in a theory level also. Okay, in CBSE theory level also you have learned these methods. So next you are using some standard limits. Standard limits. So I use some standard limits like formulas. So try to remember those formulas. Okay. The first formula is limit extends to a x power n minus a power n by x minus a. What is the formula for this? N into a power n minus 1. So from this formula we can derive this formula also. Limit extends to a x power m, or n you take a power n divided by x power m minus a power m. So formula becomes n by m into a power n minus m. So instead of remembering this formula, you better remember this formula. So you can, even if you put m value 1 here, then this formula reduce it to this. Actually we got this by using this formula only. But in case of problems, in case of objective problems, better you remember this formula. So for example, if they ask what is a limit extends to 3 x power 4 minus 3 power 4 by x square minus 3 square. So just we can apply second formula. So n by m, so 4 by 2, n value 4 a, and m value 2, what is a value? 3. So 3 power 4 minus 2. 4 by 2 is 2 into 3 square. So 2 into 3 square is 2 into 9, 18. Next second one. Second formula. Limit extends to 0. Trigonometric function. Sin x by x. It is equal to what? 1. And remember here x is measured in radians. Okay. Sin of x by x is 1. So from this we have many formulas. Limit extends to 0. Tan x by x is also what? 1. So that is derived from this formula only. And instead of remembering this formula, basic formula, better you remember these formulas. So limit extends to 0. Sin of ax by x is equal to a. Just here, what is x coefficient? That is the answer. How we got this answer? Just multiplying, dividing with a. So similarly, what is the limit extends to 0? Tan of ax by x, it is also equal to a. So next, limit extends to 0. Sine inverse of ax by x, it is also a. So similarly, limit extends to 0. Tan inverse ax by x is also a. Tan inverse ax by x is also a. Next, third one. Limit extends to 0. 1 plus x whole power 1 by x is equal to e. So from this formula only we can derive this formula. Limit extends to 0. Log of 1 plus x by x is equal to 1. That means what I did, both sides applied log. If you apply both sides log of 1 plus x whole power 1 by x is what? 1 by x into log 1 plus x. Nothing but log 1 plus x by x. Log e value 1 over. So next formula based on exponential function. Idu logarithmic, next idu exponential. Limit extends to 0. A power x minus 1 by x is log a. Ln a. So log a to the base e. So instead of a, if I substitute e, exponential constant, limit extends to 0, e power x minus 1 by x, what will you get? Log e. Log e ln e. Ln e is nothing but log e base e. Okay, so log e base e is 1. Next, last formula, limit extends to 0, 1 minus cos of ax power n divided by x square is equal to n times of a square by 2. So in this sixth formula, if you put a is equal to 1 and n is equal to 1, if you put a is equal to 1 and n is equal to 1, a value 1, n value also 1, then formula reduce it to what? 1 minus cos x by x square as x tends to 0. And if you put n value 1, a value 1, what do you get? 1 upon 2. So try to remember at least these formulas. Okay. So next, so limit of the function when x tends to infinity. Limit of the function when x tends to infinity. So how to find limit of the function when x tends to infinity? Remember basic thing, when x tends to infinity, 1 by x is tending to 0. In fact, 1 by x power n is also tending to 0 for all natural numbers n. Okay. Next, so one example for this, limit extends to infinity, 2x square plus 3x plus 4 divided by 3x square minus 4x plus 3. So if you apply limit directly, what you will get? Infinity by infinity form, which is indeterminate. So how to evaluate this kind of problems? So here we are not getting 0 by 0 form. If we got 0 by 0 form, we have to think about what? Factorization method, because both numerator and denominator are polynomials. But we are getting what? Infinity by infinity form, and also as x is tending to what? Infinity. And remember, x is tending to infinity means it is not the meaning that x is closer to infinity. Infinity is not at all a real number. Generally, x tends to a means x is nearer to a when a is a real number. But here x is tending to infinity means what? The value of x increasing indefinitely. The value of x increasing indefinitely. And similarly, when x is tending to minus infinity means what? The value of x decreasing indefinitely. The value of x decreasing indefinitely. Okay. Then come to this problem. So when x tending to infinity, this, how to evaluate this problem? So for this, one method is there. Of course, different methods are there. I am going to discuss one particular method. So what is the highest x power in the numerator? X square. And same in denominator also, same x square. So you divide numerator and denominator by x square. Or you take in the numerator x square common. Or better you remember, divide with x square. Okay? Or you take x square common. If you take x square common, I am going to write directly. So 2 plus 3x by x square is 3 by x plus 4 by x square. In denominator also, if you take x square common, what you will get? 3 minus 4x by x square is 4 by x plus 3 by x square. Now x square cancel. Now as x tends to infinity, 1 by x is 0. So using that, what you will get? 2 plus 3 by infinity is 0, 4 by infinity is 0, divided by 3 minus 0 plus 0. So what you got answer? 2 by 3. So for this also, one shortcut formula is there. Here, what is the degree of numerator? X square. Highest x power is what? 2. So degree is 2. Denominator degree also 2. So both are same. When the numerator degree is equal to denominator degree, so limit x tends to infinity, a polynomial function by another polynomial function whose numerator degree is same as denominator degree, then the answer will be leading coefficient in the numerator by leading coefficient in the denominator. So what is the leading coefficient means what? It is the coefficient of highest x power in that polynomial. So in this polynomial, numerator polynomial, what is the highest x power? X square. What is its coefficient? 2. Denominator, what is the highest x power? X square. What is its coefficient? 3. So observe the answer 2 upon 3. Because of degrees are same. Okay. So I am going to give that formula. So limit x tends to infinity, f of x by g of x. So what are the possible answers for this is, first thing is 0 if degree of numerator, NR means numerator, less than degree of denominator, DR means denominator. So your degree of numerator smaller than degree of denominator means, suppose here instead of x square, x cube is there. Here x cube is there, x square cancel, still 1x is left now. So what will you get the answer? 2 by 3 into 1 by infinity. 1 by infinity is what? 0, because your x is left now. X value infinity, if I substitute 1 by infinity into 2 by 3. So 1 by infinity is what? 0. So 0 into 2 by 3, 0. Next, it is equal to a naught by b naught if degree of numerator is equal to degree of denominator. What is a naught, b naught? Leading coefficients in numerator and denominator. Next, it is equal to positive infinity if degree of numerator greater than degree of denominator. And one more condition, this a naught by b naught is positive. Two conditions. Degree of numerator must be greater than degree of denominator, and a naught by b naught must be positive. Next, minus infinity if degree of numerator is greater than degree of denominator. And what is the one more condition? This leading coefficient a naught by b naught is less than 0. Means in this case leading coefficients having same sign. In this case, leading coefficients having opposite sign, a naught by b naught. So what is a naught, b naught here? A naught, b naught are leading coefficients of f of x and g of x respectively. Okay, if you can able to remember this formula, it is well and good. That means whenever limit x tends to infinity, f of x by g of x, well, when will get 0? Only when numerator degree less than denominator degree. When you will get a number which is non-zero real number, When degree of numerator is equal to degree of denominator. When you will get undefined, numerator degree is more. Denominator degree is more, 0. Numerator degree is more, infinity. Plus infinity when we will get plus infinity? In leading coefficients having same sign. And when you will get minus infinity, when leading coefficients are of opposite sign. And when you will get non-zero real number, degree of numerator, degree of denominator, both are equal. So some examples see based on this. So what is a limit x tends to infinity? X square plus 2x plus 1 by x square 2x square plus 3. See here, numerator degree is same as denominator degree. So answer will be leading coefficient in the numerator is 1. Denominator, what is the leading coefficient? That means highest coefficient of highest x power 2. So answer is 1 by 2. So limit x tends to infinity, x plus 2 divided by x square plus 3. So what will be the answer? Numerator degree is smaller than denominator degree. Denominator value is more. So denominator infinities are more. So when compared to number of infinities in the numerator, denominator infinities are more. So denominator some infinity will left. So denominator is some infinity left means what you will get answer? Denominator infinity means what will be the answer? 0. Next. Limit x tends to infinity, 1 minus x square by 1 plus 2x. What will be the answer? Here numerator degree is more than denominator degree. So numerator x values are more. So numerator number of infinities are more. So answer will be either infinity, so either plus infinity or minus infinity. But here we will get answer is what? Plus infinity or minus infinity? Check. Here x square coefficient is negative. Highest x power is x square. So x square coefficient is negative. Here highest x power is x power 1 and its coefficient is plus. So opposite signs. So answer is minus infinity. Same sign, plus infinity, opposite sign, minus infinity. Suppose next limit x tends to infinity, 1 plus x cube divided by 1 plus x square is there. So answer will be what? Plus infinity, because numerator highest x power is x cube, its coefficient is plus 1. Denominator highest x power is x square, its coefficient is plus 1. So both are having same sign, the leading coefficient having same sign, and also degree of numerator more than degree of denominator. So answer will be plus infinity. Now this is the previous year mains problem. See here. So previous year mains problem. And before that, I am doing one more problem. Limit x tends to infinity, x into sine 1 by x. So if we apply limit directly, what you are getting now? Infinity into 1 by infinity is 0. Sine 0, 0. So 0 into infinity form. So 0 into infinity form means it is indeterminate form. So try to convert it as into 0 by 0 or infinity by infinity form. So I am going to write like this, limit of sine of 1 by x into x I am writing divided by 1 by x. When x value infinity, what is 1 by x value tending to 0. So now we can use limit theta tends to 0, sine theta by theta is 1. So instead of theta, what do you have? 1 by x. But the theta is tending to what? 0. So thus the answer is what? 1. So now look at one more problem in factorial notation. Limit n tends to infinity, n plus 2 factorial plus n plus 1 factorial divided by n plus 2 factorial minus n plus 1 factorial. So here also don't try to apply the limit directly, we will get indeterminate form because infinity plus 2 is infinite, infinity factorial is again infinite. So what you are getting? Infinity by infinity form. So don't apply the limit directly. Then how to evaluate? So when factorial terms are given, just you identify what is the least factorial. So among these two, n plus 2 and n plus 1 factorial, which is the least factorial? N plus 1 factorial. So you take n plus 1 factorial is common. And how to write n plus 2 factorial in terms of n plus 1 factorial? N plus 2 factorial is equal to n plus 2 into n plus 1 factorial. N plus 2 into n plus 1 factorial. N plus 2 factorial is equal to n plus 2 into n plus 1 factorial. So that means in both both terms in the numerator, what we can take common? N plus 1 factorial. Then what is the left in the numerator? N plus 2 here plus 1. And denominator also same only, no? N plus 1 factorial, here n plus 2 minus 1. So n plus 1 factorial get cancelled. Then what you will get numerator? Limit n tends to infinity. N plus 2 plus 1 is n plus 3 divided by n plus 2 minus 1 is n plus 1. Observe this. Here numerator and denominator both are polynomials in n. And if you apply limit directly, you will get infinity by infinity form. Then we can use that formula, above formula. Numerator, denominator both are polynomials of same degree. So as n tends to infinity, as numerator degree same as denominator degree, so what will be the limit of this function? Leading coefficient in the numerator by leading coefficient in the denominator. So here highest to n power is what? 1, and its coefficient is also 1. So leading coefficient is 1. Here also n power 1 and its leading coefficient is 1. So 1 by 1 is 1. Or else you can divide numerator and denominator by n and use as n tends to infinity 1 by n tending to 0. You will get same answer 1. Next problem. So limit n tends to infinity, we have this problem in our book, 1 plus 2 plus 3 plus and so on plus n into 1 plus 1 square plus 2 square plus 3 square and so on plus n square divided by n times of 1 cube plus 2 cube plus 3 cube plus and so on n cube, where n is a natural number. So n is a natural number and n takes only natural number values, natural numbers, and it is approaching to infinity. So this kind of series model problems are came. Just you find first sum of those n terms. Okay. So sum of these n terms we have already formula. What is the formula? N into n plus 1 by 2. And this is the sigma n square form is what? N into n plus 1 into 2n plus 1 by 6. Whole divided by n into, what is sigma n cube formula? N square into n plus 1 whole square by 4. So cancel n into n plus 1, n into n plus 1 cancel. Again here n into n plus 1, n into n plus 1 get cancelled. And here 2 1, 2 2s, 2 1s are 2 3s are. Then what is the left in the numerator? 2n plus 1 by 3. Denominator is n, so 3n. Here also you can use the above formula because both numerator and denominator are polynomials. Degrees are same. So leading coefficient by leading coefficient. Here leading coefficient is 2, here leading coefficient is 3. So because your n is tending to what? Infinity, na? Tending to infinity. So thus the answer is 2 by 3. Or else you can divide numerator and denominator by n and use as n tends to infinity 1 by n tending to 0. So thus the answer is here 2 by 3. So next, this one is the previous mains problem. Previous mains problem. So if limit extends to infinity, x cube plus 1 divided by x square plus 1 minus of ax plus b. This is normal bracket only, okay? It is not greatest integer function brackets, okay? It is equal to 2. So given that limit of this function is exist and finite and it is non-zero number 2, okay? It is a limit of this function is exist and finite, and it is some non-zero real number which is it is equal to particularly 2. Then we have to find the unknown numbers a and b, unknown constants a and b. So first you simplify this. Take LCM, make it as a rational function. That means numerator some polynomial, denominator is some polynomial. So limit extends to infinity. If you take x square plus 1 as LCM, what do you get? Numerator x cube plus 1 minus of x square plus 1 into ax plus b is equal to 2. So now I'm writing directly. So limit extends to infinity. So numerator I'm multiplying and grouping like terms. Here ax cube, here x cube, minus ax cube, x cube. If you take x cube common, what do you get? 1 minus a. Next to next here, what do you get? X square terms minus bx square. Next to minus ax. Next to minus b plus 1 divided by x square plus 1 is equal to 2. So remember above formula, above problem, above formula. In the above formula, you observe the second case. When we'll get a naught by b naught? So that means when the degree of numerator is equal to degree of denominator. In all those four cases, where we are getting a non-zero real number, because it is in the form of limit extends to infinity f of x by g of x. And what we got this number 2. So 2 is a real number, non-zero real number. So in which case we are getting non-zero real number? First case we are getting 0. Third and fourth case we are getting infinity. Only we are getting in second case only a non-zero real number. So in second case, so if you observe when we'll get that a naught by b naught, under what conditions? Degree of numerator must be equal to degree of denominator. So here also degree of numerator must be equal to degree of denominator, then only limit of this function is exist and it is equal to some finite non-zero real number. Okay, so here degree of numerator, degree of denominator must be same agbeekandre. So compulsory this x cube term irbardu. So it should be not appear. It should not be appear. It should not be appear means it should be absent. It should be absent means this coefficient must be equal to what? 0. So that means it is possible only when 1 minus a value 0 and b value not equal to 0. Why b value not equal to 0? If b value is 0, then it cannot be a quadratic because the denominator is quadratic. So when we will get non-zero real number, if degree of numerator, degree of denominator must be same. Here degree of denominator what you got? 2. So degree of numerator also must be equal to what? 2 only. So when degree of numerator is equal to 2, when this x cube term should be absent and x square term should not be absent. So that's why it should be absent means 1 minus x coefficient 1 minus a must be equal to 0. It should not be. So x square term should not be absent means its coefficient minus b should not be equal to 0 or b not equal to 0. So thus if you substitute 1 minus a value 0 here, then the problem becomes what? Minus bx square minus ax plus 1 minus b divided by x square plus 1, it is equal to 2. As degrees are same, then what is the limit of this function according to that formula? Leading coefficient in the numerator minus b, leading coefficient in the denominator is 1, which is equal to 2. So minus b by 1 is equal to 2 means b value is how much? Minus 2. 1 minus a value 0 means a value is how much? 1. Okay. So you take homework problem. Homework problem is same problem. Instead of here 2 you take 0. Same problem. Limit of this function is equal to 0 you take. So when we'll get 0? In first case. First case means degree of numerator must be less than degree of denominator. So and you will get a value same 1. But you will get, if you take 0, b value, you will get 0. A value 1, b value 0. In homework problem, you have to get a value 1, b value 0. Thank you.